Hello again and welcome back. Very short one today. In this video we'll be looking at the penetrating power of radiation. Outcomes today. You have to be able to state the ranges of alpha, beta and gamma in air and give examples of the materials and their relative thicknesses that will stop each type of radiation. So the penetrating power describes how far each radiation will travel through materials. Each radiation will travel until it's absorbed by another material. How far it travels depends on the size of the particle, the ionising power of the particle, and the density of the material that it's travelling through. Alpha particles are the largest of the three types of radiation and the most ionising. Because of this, alpha finds it difficult to pass through any material at all, even gases like air. Because they're large and ionising, the alpha particle will be able to move around 3 to 5 centimetres in air. However, it won't be long before it collides with one of the particles in the air. When this happens, it will ionise the particle and be absorbed. Alpha particles are so big and highly ionising that they won't be able to travel through any solid materials at all. Alpha particles can't travel through paper or skin. They'll be absorbed too easily. Think of it like trying to drive a lorry through a forest. It won't get far before it's stopped by the trees. Now, this is generally good news for us, as alpha particles can cause a great deal of damage to our health if our internal organs absorb them. The fact that they can't travel far means we only really need to worry about them if we eat or breathe some source in. So to recap, alpha, they are the largest and the most ionising of the three, so will be absorbed more easily than the others. They'll travel through a few centimetres of air and are stopped by any material, even ones as thin as paper or skin. Beta particles are much smaller and less ionising than the alpha. Because of this, they'll travel further in the air, a few metres, and are not stopped by thin materials like paper at all. To stop beta, we need a more dense and thicker material. 2 or 3 millimetres of aluminium will do this. It's like trying to launch a golf ball through the forest. It will get further than the lorry will, but to stop it in its tracks we really need a denser forest. Gamma is not a particle at all and is the least ionising of all the radiations. Because of this, they'll not be stopped significantly by air or any thin material of low density. To stop gamma, we need to use a very thick and dense metal like lead. 2 or 3 centimetres of lead will do the trick. It's like shining a torch through the forest. Some of the light will likely reach pretty far into the woodland. Despite gamma being the least ionising, it can penetrate further into the human body than alpha or beta, perhaps allowing it to damage cells inside the vital organs. In a later video we'll see how we can actually make use of this fact, because we can use gamma in medical treatments. Please be aware that the thicknesses suggested in this video are just estimates. Any material of any thickness and density will absorb some radiation, but it might not be very effective. Even a few centimetres of lead will not absorb all radiation. But the thicker and denser the material, the more it will absorb any incoming radiation. The guidelines given in this video are just useful estimates of how to stop the vast majority of each of the three types. So, to recap, alpha is effectively stopped by 3 to 5 centimetres of air and won't penetrate skin or paper. Beta by 2 or 3 millimetres of aluminium, and gamma by 2 or 3 centimetres of lead. Only one example for you today. A radioactive source emits alpha, beta and gamma radiation. Sheets of aluminium and paper are placed close to the source as shown. Which row in the table shows the radiations from the source detected at points X and Y? Pause the video, think about what answer you would select. So your answer here must be E, gamma and gamma. Now why is that? So the radioactive source is on the left of the diagram, and in order to get to point X, radiations have to pass through 4mm of aluminium. We know that alpha cannot get through aluminium, and beta can get through some aluminium, but 4mm is a bit thick. Remember, beta is usually stopped by 2 or 3mm of aluminium. So at point X, we would tend to find gamma radiation at that point. What about point Y? Well, we've only really got the gamma getting through the aluminium, and gamma's not stopped by paper, so it's not going to have any effect at all. So we'll find gamma at points X and Y. Very briefly, the outcomes today. State the ranges that alpha, beta and gamma will travel in air. So alpha will travel 3 to 5 centimetres, beta and gamma, beta will travel several metres, and gamma really won't be stopped by air very effectively at all. And give examples of materials and their thicknesses that will stop each type of radiation. So alpha will be stopped by anything even very thin, low density materials like skin or paper. Beta won't really be stopped by the paper, we need 2 or 3mm of aluminium for that. And to stop gamma, we need 2 or 3 centimetres of lead. I hope you found this lesson useful. Please like and subscribe, and I'll catch you for the next. Cheerio.